curious to look around the room you're in right now. Feel the weight of your device. Recall what you ate for breakfast this morning. It all feels solid, real, and undeniable. But the math of probability suggests a statistical likelihood that none of it exists. You aren't sitting in a room. You don't have a past. Instead, the numbers suggest you are a single, disembodied brain, fully formed with a lifetime of fabricated memories, floating entirely alone in a dark, empty void. In physics, this thought experiment is known as a Boltzmann brain. The Boltzmann brain is a severe thermodynamic paradox, a mathematical challenge forcing cosmologists to reevaluate how the physical universe actually operates. The puzzle begins in the late 19th century with Austrian physicist Ludwig Boltzmann. He was trying to identify why things age, decay, and break down, why the flow of time only moves in one direction. He found the answer in the Second Law of Thermodynamics. This law states that any closed system inevitably moves from a state of order toward a state of complete randomness. This measurement of disorder is called entropy. This is the equation Boltzmann used to define entropy. S represents entropy, and W represents the number of possible microscopic states a system can be in. Because there are vastly more ways for particles to be chaotic than ordered, chaos naturally wins out over time. But Boltzmann noticed a loophole. If a dead universe exists in a high entropy state for an infinite amount of time, particles randomly bumping into each other will eventually, by sheer luck, arrange themselves into a structured shape. Physicists call these statistical fluctuations. Given an infinite timeline, those random atomic collisions can theoretically build an apple, a chair, or a star system. The universe we observe today, with billions of galaxies and intricate biological systems, exists in a state of low entropy and high organization. In thermodynamics, highly organized systems require specific, rare configurations of particles to assemble randomly. We refer to this requirement as thermodynamic cost. This visual scale compares the costs. Generating a 93 billion light-year-wide universe requires a vast amount of organization. However, randomly assembling a single human brain requires a minimal cost by comparison. Random fluctuations follow a strict statistical law. They will always favor the simplest, most localized outcome over a large, complex one. In a universe of infinite time and total chaos, small fluctuations occur far more often than large ones. For every one time a full universe might assemble by chance, a single brain would materialize trillions of times over. If our existence is just a random accident of physics, you are statistically more likely to be the simpler, cheaper anomaly. Every relationship you have and every physical sensation you feel would be a momentary fabrication, a glitch in the vacuum that lasts for a single second. If the cosmos arose from a random thermodynamic fluctuation, human reality is a mathematical impossibility. Modern physicists do not actually believe we are floating brains. They accept that we are real biological observers. Instead, they use this scenario as a reductio ad absurdum. It is a diagnostic tool designed to test the logic of a theory by pushing it to its breaking point. This chart shows the test in action. If a cosmological model predicts that Boltzmann brains outnumber real observers, physicists flag that model as mathematically unstable and discard it. Physicists treat this paradox as a forensic tool to verify the stability of their models. To solve the paradox, science relies on theories like the Big Bang and cosmic inflation, which indicate our universe did not emerge from a random fluctuation in an eternal vacuum. These models show that the universe began in a precise, low entropy state and has been naturally expanding and evolving ever since. If you want to keep exploring the hidden, highly ordered structures of our reality, subscribe and join us as we decode the physics of the universe. The laws of physics suggest that your reality is real. Probably,